Welcome to the lecture series of Basic Electrical Engineering. The subject code is ECE 101. The topic of today's video lecture is Superposition Theorem. Superposition theorem states that in any linear active bilateral network having more than one source, the response across any element is the sum of the responses obtained from each source considered separately, and all other sources are replaced by their internal resistance. The superposition theorem is used to solve the network where two or more sources are present and connected. As shown in this figure, we have seen that there are two voltage sources V1 and V2. When we are solving this network, we considered one voltage source at one time. When we are considering V1, we short circuit V2, and if V2 is having some internal resistance, then we replace this with its internal resistance or we make it short circuit. And in the second step, we consider V2 and short circuit V1 or replace it with its internal resistance. And in the third step, we will take the overall result of the currents. Or in other words, it can be stated as if a number of voltage or current sources are acting in a linear network, the resulting current in any branch is the algebraic sum of all the currents that would be produced in it when each source acts alone, while all other independent sources are replaced with their internal resistances. As I have told you that when we are considering one voltage source, the other voltage source is replaced by its internal resistance. It is only applicable to the circuits which is valid for the Ohm's law. That is, superposition theorem is applicable only for the circuits which obey Ohm's law, and means that the circuits who are linear circuits. Now we explain the superposition theorem. Let us consider the superposition theorem with the help of an example. The circuit diagram, this diagram consists of two voltage sources V1 and V2 and some resistances R1, R2 and R3. First, take the source V1 alone and short circuit the V2 source as shown the figure. As shown in this figure, we short circuit this component and we short circuit this like this. This is the short circuit, and the directions of current according to this voltage source, this is I1 dash, I2 dash and I3 dash. So the value of current flowing in each branch is I1 dash in R1, I2 dash in R2 and I3 dash in R3. So next step we find out the values of I1 dash, I2 dash and I3 dash. So I1 dash is equals to applied voltage V1 upon the total resistance. Total resistance, these two resistances are in parallel with each other. So R2 into R3 upon R2 plus R3 plus these two are in series with this plus R2. So I1 dash is given by this equation V1 upon the total resistance. Similarly, we find out I2 dash. I2 dash is given by this equation. I2 dash is equals to I1 dash, which we find in equation 1, upon R3, this R3, upon R2 plus R3. So the difference between I1 and I2, I1 dash and I2 dash is the I3 dash. So this is I3 dash. I3 dash is equals to I1 dash minus I2 dash. So this is how we find out the three currents when we considering the applied voltage V1 only and short circuit the other voltage. This is the main diagram in which we are having the two voltage sources. This is the second diagram when we are considering the V1 voltage source and we short circuit this voltage source V2. Then now activating the voltage source V2 and deactivate the voltage source V1 by short circuiting it. Now find the various currents, that is I1 double dash, I2 double dash, I3 double dash following the circuit as shown here. Now in this diagram we are considering V2 voltage and we make it short circuit. We short circuit the V1. Now the directions of current are in according to this voltage source. This is I2 double dash, I1 double dash and I3 double dash. Now we find out the values of these three currents. So I2 double dash is given by V2 upon this I2 double dash is given by the applied voltage V2 upon the total resistances. These two are in parallel. So R1 into R3 upon R1 plus R3 plus R2. R2 is in series with this combination. So I2 double dash is given by V2 upon the total resistance. Similarly, we find out I1 double dash. I1 double dash is equals to I2 current, which we find here into R3 upon R1 plus R3. So this is how we find out I2 double dash and I1 double dash. Similarly, in the previous case, I3 double dash is a subtraction difference between the two currents, I2 double dash minus I1 double dash. Now we find out the values of currents in both the circuits. When we are considering V1, we find out I1 dash, I2 dash and I3 dash. When we considering the second voltage source V2, we find out the currents I1 double dash, I2 double dash and I3 double dash. Now as per the superposition theorem, as we have told that we stated in the superposition theorem that it is the summation of algebraic summation of the currents. So I3 current is given by the summation of two I3s, I3 double dash plus I3 dash plus I3 double dash. Now look into this. Both the currents are flowing in the same direction. So here we are considering the plus sign. Now I2 is the summation of I2 dash and I2 double dash. I2 dash current is flowing in this direction, in the arrow is towards the right, and I2 double dash is in the opposite direction. So here we are having the negative sign. And similarly I1 is equals to I1 dash minus I2 double dash. So this is also in the opposite direction. The direction of the current should be taken care while finding the currents in the various branches. So this is important. We should take care the direction of the currents. Now we consider the steps for solving network by superposition theorem. First of all, considering the circuit diagram, let us see the various steps solve the superposition theorem. We are having some circuit in which we are having the E1 voltage source, E2 voltage source, and E1 is having the internal resistance R1 and E2 is not having any internal resistance. Now we are applying the superposition theorem on this circuit. When we are applying the first step, we are considering the voltage source E1 and we short circuit the other voltage source. E2 is short circuit. So step 1 is take only one independent source of voltage or current and deactivate the other source. We are deactivating the other source. Step 2, in the circuit diagram shown in the figure, consider the source E1 and replace other source E2 by its internal resistance. If internal resistance is not given, then it is taken as 0 and the source is short circuited. As given in the circuit, we are not having the internal resistance, so we are considering 0 internal resistance and we make it short circuit. Then step 3, if there is a voltage source, then short circuit it, and if there is a current source, then just open circuit it. It is a very important step, so always keep in mind that whenever we are having the voltage source, make it short circuit, and when we are having the current source, then make the circuit open. We are not considering this wire. We are making the circuit open circuit. Then step 4, by activating one source and deactivating the other source, find the current in each branch of the network. Taking the above example and find out I1 dash, I2 dash and I3 dash. As in the previous, we find out the currents. So when we are considering one voltage source, we are finding out I1 dash, I2 dash and I3 dash. As shown in the figure, we are replacing E1 replacing E1 by its internal resistance and E2 voltage source. The currents flowing in the circuit is I2 double dash, I1 double dash and I3 double dash. So similarly, step 5, when now consider other voltage source E2 and replace E1 by its internal resistance R1 as shown in the circuit. Step 6, determine the current in the various sections I1 dash, I1 double dash, I2 double dash and I3 double dash. We find out the values. Then step 7, now to determine the net branch current, utilizing the superposition theorem, add the currents obtained from each individual source from each branch. I1 is the resultant current of the two circuits. It is given by I1 dash minus I2 double dash, and I2 is equals to I2 dash minus I2 double dash. I3 is equals to I3 dash minus I2 double dash. I1 dash is the current when we are considering the voltage source E1, and I2 double dash is the current when we are considering the voltage source E2. Similarly, I2 dash is the current when we are considering E1 and I2 double dash is the current when we are considering E2. So, I1 is the resultant current by the superposition theorem, and I2 is the resultant current and I3 is the resultant current. So last step, if the current obtained by each branch is in the same direction, then add them, and if the current is in opposite direction, then subtract them to obtain the net current. As here these are the net current values and we make it plus or minus according to the direction of the flow of the current. So overall equations, actual flow of the current in the circuit will be given by the equation I1 is equals to I1 dash minus I1 double dash. I2 is given by I2 dash minus I2 double dash, and I3 is equals to I3 dash minus I3 double dash. So this is all about the superposition theorem. Hope you like this video. Thank you so much.